The VM. Okay. It's been a few days. Feels kind of kind of the same, really. Hang on. Why is it so quiet? Too loud. Either too quiet or too loud. Weird. Weird. Okay. Let me. I can zoom in all the way. I don't know. Sig test source compiler. Okay, yeah, I do remember this. How long has it been? 3 days? Yeah, something like that. So it's Tuesday. Saturday, Sunday, yeah, 3 days. Almost didn't. I was like, oh, I'll take another day off. I find that the more days I take off in between, the higher the chances that I'll not that I'll quit. At least it has been true for me in the past. So my strategy is to just do it every day, if almost every day, if not every day. Yeah. Okay, here we go. So now that's out of the way. I do like it when nobody's watching. I can say whatever I want. Kind of nice. Yep. Okay, so executing functions. So we've compiled functions into bytecode, and we need to change this bytecode into, well, yeah, we need to execute it now. If I can remember, fuck, it's still function calls. Okay. Just want to make sure I'm on the right page. I'm not sure if I did. Oh no, I did. Fuck, it's been a while. So I did a lot more than I thought I did. Nice. Functions in the VM. Here's the situation and task at hand put into the vocabulary of our VM. The bytecode's constant field can contain object.compile functions. When we come across an opcall instruction, we need to execute the instructions of the object.compiled function sitting on top of the stack. We do that until we encounter either an op return or an op return instruction. If it's an op return value, we need to preserve the value on top of the stack, the return value. And we have to remove the just executed object.compiled function from the stack. I read those lines, but I have no idea what they said. The bytecode's constant field can now contain object.compiled functions. When we come across an opcall instruction, we need to execute the instructions of the object.compiled function sitting on top of the stack. We do that until we encounter either an op return value or an op return instruction. If it's an op return value, we need to preserve the value on top of the stack. What was the difference again? Operate. Hang on. I guess I decided not to have implicit return. Or only have explicit return. If it's an op return value, we need to preserve the value on top of the stack, the return value. Then we have to remove the just executed object.compiled function from the stack and replace it with the saved return value, if we have one. Gotcha. Because object.compile function contains the instructions that need to be executed within that scope. So after it's executed, we've got to remove that and add whatever it was, whatever's the last value, if there is one. Yeah, the question is, how do we execute the instructions of a function? How do we execute instructions at the moment? What if we created another virtual machine? How much memory does this use? Okay. That's quite a lot of memory. Because then at some point we'll still need not sure really. Means that the virtual machine's main loop iterates through VM instructions sliced by incrementing its instruction pointer and using it as an index to fetch the next opcode from VM instructions. It also reads the operands from the same slice. When it comes across a branching instruction like op jump, it changes the value of instruction pointer manually. Okay. When we execute functions, we do not want to change this mechanism. The only thing we want to change is the data it uses. The instructions and the instruction pointer. If we can change those while the VM is running, we can execute functions. Okay. So somehow the instruction pointer should only move once while it executes. I mean, I guess it's fine. Yeah. I think that's not too bad. What does it mean? The only thing we want to change is the data it uses. Kinda. Right? Because you can still use values that are within its scope. But I guess you would check if it's defined within the current scope before you look outside. Changing a slice and an integer. That's not a challenge, I know, but that's not all of it. We also need to change them back. When the function returns, we need to restore the old instructions and the old IP. Not just once, we also need to handle nested execution of functions. Yep. So they need to be changed again. One is called and two, so again. Right. Okay. So I think kind of manually changing it doesn't make sense. Because you can very easily lose track of it. Hang on, if you read the last paragraph, a little bell with stack written on it began ringing in your head, you're on the right track. No bells were ringing. Okay, let me read this again. When 3 is called, and the instruction okay, when 3 is called, the instructions and the instruction pointer need to be changed. Yeah, then 2 is called, so they need to be changed again. Okay, so it's nested, right? 1 is called into, so again, and the instruction pointer. And then finally, once 1 is executed, we need to restore the instructions. And the instruction pointer, as we left them into before the call. Right, okay. I see what it means. So we're like pushing stuff onto the stack. And every time, I think I got kind of confused when he said you got to replace. You can just add it to the stack, right? And then once whatever's left over, you leave that value and you pop the rest. Because this entire thing is an object. Okay. Adding frames. This is what we know. Function calls are nested and execution relevant data. The instructions and the instruction pointer is accessed in a last in first out manner. Yeah. Yep, correct. So if you execute one last, then you gotta pop that. Yep. Masters of the stack. So this plays into our hands, but juggling two separate pieces of data is never pleasant. The solution is to tie them together and call the resulting bundle a frame. A frame is short for call frame or stack frame, and the name for a data structure that holds execution relevant information. In compiler or interpreter literature, this is also called activation record. Okay, cool. I like the sound of it. On real machines, computers, frame is not something separate from a designated part of the stack. It's where the return address, the arguments to the current function, and its local variables are stored. And since it's on a stack, a frame is easy to pop off after the function has been executed. As we saw in the first chapter, using the stack to save call frames is what turns it in from a stack into the stack, and more specifically the call stack. Right. In virtual machine land, we don't have to use the stack. We're constrained by standardized calling conventions and other much too real things like memory address and locations. Using Go instead of assembly language and building a virtual machine have more options available to us than the builders and programmers of real machines. Getting distracted by my own voice. We can store frames anywhere we like, any execution relevant piece of data, actually. What's kept on the stack and what's not differs from VM to VM. Some keep everything on the stack, others only the return address, some only the local variables, some the local variables and the arguments of the function call. There is no best nor an only choice for these decisions. The implementation depends on the language being implemented, the requirements in regards to concurrency and performance, the host language, and much more. Okay. Since we're here to learn, we choose the easiest to build, to understand, to extend, and what also allows us to see how it might be changed or implemented differently. We already use our VM stack in parts as a call stack. Save the function to be called and its return value on it. But we're not going to keep our frames on there. Instead, they'll get their own stack. Okay. Mm-hmm. I have no idea what I just read. Weird noises. But before we build that, here's what makes up a frame in our VM. Okay. Right, okay. I see. That's not too bad. So the instruction pointer is the one that needs to be replaced once the function's executed. Totally distracted there. Didn't know what I was thinking about. Right. Don't know why it's private. The frame is two fields, IP and function. Function points to compile function. IP is the instruction pointer in this frame for this function. I'm guessing the IP for the return statement. The frame being currently executed is the one sitting on top of the call stack. Yeah, I think it doesn't make any sense to write tests for it. Okay, we've got two options now. Changing our VM to only use frames when calling and executing a function. Which modifies, or the other one is modify the VM so that okay, I see. Actually, the second option seems a lot better. Yeah. It is a lot more simpler too than to like keep track of the frames later. The visible behavior of the VM should not change one bit. Let me now change to use frames. It's an internal change only, and to make sure that a VM keeps on working. Yeah, exactly. It's a slice of frame. So frame 0 is always the entry point, or like the main function, so to speak. Okay, you can get the current frame, push frame, pop frame. Right. Use a slice of the underlying data structure and an integer as index. Use slightly different, since it's nice to have a little bit of performance here. Use a different approach than the one used in the compiler for the scope stack. Instead of appending and slicing off, we pre-allocate the frame slice. Max frames. Okay. That makes my life easier. You can just use an array. Nice. Because I don't hate using array lists, but just don't. It's too tedious in Zig to use an array list. I prefer using an array. And just it's a lot easier. I mean, it's not that tedious. I'm making it sound like it's a lot of work. It's not really. Okay, got fixed number of frames. Then yeah, I guess you make a now the question is, do I need to here? I think I might need to allocate. Maybe, not sure. Yep. What goes on in the frame anyways? Push frame. Hang on. Okay. Frame index is okay. I think I'd rather keep it 0 and then just increment the index before. As the first thing, we create a main function as the fictional mainframe that contains bytecode.instructions, which make up the whole monkey program. Then we allocate the frame stack with a maximum of max frames slots. The value of 1024 is arbitrary but should be enough for us as long as we don't nest function calls too much. The first frame on this new frame is called main frame, and then following the fields we already know, we put the frames excuse me, and the frame index of 1 into the newly created VM. We've removed the initialization of the instructions field in this new function, and now need to remove it from the definition of VM2. What do you mean? Oh, right. Okay. Gotcha. What was the... Okay. Got rid of the instruction slice. With the instructions slice gone, we now need to change the way we access the instructions and the instruction pointer inside the VM, and make sure that we always access them by going through the current frame. Okay. The first change we need to make is in the VM's main loop. Ah, I see. So the IP would now belong to the frame. Increment the IP manually in its body. But this is private. How do you access that? Oh, because it's in the same package. I see. I wonder how you can achieve the same in Zig. Public. struct fields in same file in zig visible to each other, or they need to be explicitly marked public. Okay, so I can just have them be in the same field. So a file in zig is the same namespace. Import namespace. You only see the public elements. Yes. And okay. Damn. I think the instructions are accessed almost everywhere. Why not just have it here? I don't get it. Okay. Also something I've wondered. Not sure if Zig has the plus plus operator. Where's the table? Yeah, that's what I thought. Interesting. Couldn't frame dot instruction pointer. Okay. Seems kind of redundant. Oh no, actually it does make sense. Okay. We had 3 helper variables at the top of the run method, so the rest of it doesn't become right. Okay. Doesn't become crowd over calls to current frame, especially since we now need to update every place in run where we either read an operands or access or modify the instruction pointer. Okay. Damn. That's oh, I can just search and replace. Okay. Executing function calls. Okay. Fuck. I'll add the frames, because otherwise I won't remember. Const struct. Let's go the instruction pointer, which is or should I make it usize? No, don't really like usize. And then guess instructions. No. An object. What is the instruction object? Is a pointer to object dot function something. Function instruction. Probably should rename this. Okay, instructions. we need new frame. Guess I can just skip this. Instructions. Yeah, I gotta get rid of that. Pointer to frame. Frame index is U64. Was it max frames? U8. Is that correct? No, that's 256. $10.24. Okay. Where was I? Yeah, okay. Here. New VM. I might need a new frame method. New frame takes instructions. What's the type? Slice of U8. Yeah, I think that's okay. And then allocator tens pointer to frame. Function instructions equals to create catch. No. I think you should create frame. Yeah, I think that can just be a copy. Probably never change. Frame equal to instruction pointer 0. Instruction object instructions. Maybe I think it can be const. Doesn't need. It does need to be modified. I know it'll be a const pointer. This can still be modified. I'm guessing. We'll see. So here, need to replace with frames. Defined dot frame index equals 0. Pm dot frames of 0 equals frame instructions comma allocator. Guess I can get rid of that. Then sp was I keeping track of? No, that's the stack pointer. Instruction index. Okay. I gotta get rid of that too. Okay. Delete. Then delete that. Yep. This is going to be vm dot fuck. Okay, I'll add another method. Current frame. Or current instructions. Pointer to frame. What does it return? Slice of U8. I mean, this could be const U8. Maybe. I'll leave it as is for now. Current index. Instructions. Might have to type that a few times. Dot frames of How did he do it? VM dot current. Oh, okay, I can see. Yeah, I forgot about that. Yep, that makes a lot more sense. And don't need that. Current frame self pointer to VM returns pointer to frame. Okay. Check dot function instructions returns nothing. Hang on. I just realized I might have made a mistake. New frame. Okay, no, it's fine. Instructions and allocator. Yep. X plus equals 1. And self dot frames of self dot frame index equals new frame instructions self dot allocator. Okay, and then it is a pointer. Can't be null. Okay. I know. I just drop. Hmm. I don't know if that's the best way to do it. It's gonna just keep using memory. Fuck. Guess go to new. What if I made this an array of frame? Nah, because I do need to be able to modify the index. Now I'm thinking, do I even need to allocate it? Because the array is, it's an array of pointers of frames, so that should work. And then when I remove frame, don't even need to worry about it. Just frame index is greater than equal to 1. Okay. Now I can fix self dot current frame dot pointer less than current frame dot instructions dot len. Excuse me. And this would change from self dot current frame dot IP. Yep. There was one more thing that I forgot. So instruction is frame dot instructions of frame dot IP. Should be more than one. Self dot instructions instruction index to frame B. Because there's a dot. Escape that. And there's one more. Yeah. No? Okay, hang on. There's a better way. Instructions say frame dot instructions. So be frame dot IP. Okay. Frame dot IP. Now there should be more places. Cube. Hang on. Instruction index. No, not all of it. What happened to this? Oh fuck, I think it replaced. Yep. Instructions. I think my search and replace went wrong. Let me undo it. Okay. It's just tedious work. Forgot how do you run the last macro? Oops. Is it at? Yeah, it is. Oops. Damn, how many are there? Okay, I think that's the last of it. Let's see. I think there's gonna be a few compiler errors. Yep. Oh, that's an easy fix. Yep, I don't need the pointer. Oh no, I do need it. The question is, I think const pointer is fine. Oh no, I can't, because I need to be able to change it later. Oh, it doesn't say const frame. Motherfucker. Do I have to do pointer cast? Pointer. Removing const qualifier. Const cast. Okay. Self dot current frame. And that's a typo. What did I call it? Current. Okay. No field name. Yep. That does make sense. Yep. VM32. Yeah, I did consider this. I think this could be a const. So I don't really need to modify the instructions. Mm-hmm. 67. Oh no. Fuck. But instructions. I think there's a few of these. Frame dot instructions. Okay. 207. Yeah. And there should be more. 216. Okay. Jeez Louise. That was just adding. Not even done the real deal yet. All of this is done. Okay, executing function calls. That's a job for tomorrow. Yeah. Okay. Do you know what? I thought today might be a lot harder because I didn't stream for a few days. But every time I stream, I realize it's a lot of fun. I do like it. And it's like free motivation to finish side projects. It's a very effective tool. I like it. All right, okay. I'm gonna call it a day there. I mean, that was fucking boring as fuck. I understand. I wouldn't watch it myself. It's just tedious work. But it was a lot of fun for me. I love all of it. This is fun. Okay, that's it. I'll see you tomorrow. And